Welcome! You are here, and that is enough. Tonight, we will take a long, quiet walk with something very small. Not a bird or a leaf or a pebble, but a tiny piece of plastic that slips through the world with the patience of dust. A gentle traveler whose journey seems unremarkable, whose steps are quiet and light, and yet, given time and distance, this long walk changes oceans in ways best considered in a slow whisper. Please settle in, soften your gaze or close your eyes if that feels kind, and let your breathing find a steady, comfortable tempo. If you enjoy falling asleep to calm science stories, a kind tap on like and subscribe helps us keep releasing these soft explorations. And you can start the Sleepy playlist linked in the description to keep learning as you drift off. What city country are you watching from right now? Imagine yourself as small as a grain of sand, resting on the edge of a sidewalk at the end of a quiet afternoon. The pavement is warm in the last light. Tiny ridges in the concrete hold a little dust, a few crystals of road salt, a bit of plant fluff, and here, almost invisible, a speck of plastic with edges smoothed by time. It does not glow or hum or spark. It is simply there, the way a crumb might rest on a table after tea. You let your attention soften. You listen to faint traffic, a distant bicycle bell, a steady breeze that curls along the curb and lifts a ribbon of dry leaves. The tiny plastic piece is no larger than a fingernail clipping. Some fragments are even smaller, like confetti dust. They are called microplastics, often defined by their smallness, usually less than 5 millimeters, often much smaller than that. Shapes vary. There are threads and fibers shed from clothing, brittle shards broken from coffee lids, rubbery flecks that once lived on a tire, tiny spheres called microbeads from old cosmetic scrubs, and small pellets that people in factories call nurdles, shaped for the convenience of manufacturing, released by accident into the world. The little piece on the sidewalk could have come from any of these, though its story does not boast or announce. It lies still. The air cools as the sun lowers. A faint scent of dust and rain hangs over the street, one that the mind interprets as quietness. You imagine the whisper of water that is not here yet but is coming. A cloud cover moves in, gathering its thoughts, and then without hurry or drama, the first drop lands. It darkens the concrete in a round coin of dampness. The next drop and the next form a soft, dotted pattern, then a sheet of rain that washes the surface in a soothing hiss. The sound seems to polish the air. The little plastic speck lifts and slits and settles, lifted again, moving by small increments as the water finds slope and direction. The curb holds a shallow stream that builds slowly, not as a torrent, but as a gentle conveyor. The fragment drifts along with grass cuttings and tiny pine needles and the thin yellow text from the spine of a paper label that once wrapped a bottle. Everything moves together as if the street had decided to exhale. Imagine the speck catching for a moment on a grain of sand, then easing free. Imagine it nudging a tiny bubble, then gliding on. Beneath the water, the concrete is textured like the surface of an old ceramic pot. There are small pits and grooves where silt pauses and resumes, where the vehicle of rain chooses one route and then another. There is a gentle rhythm to the regulation of flow, the way every bump and notch matters at this scale. The speck passes a storm drain that breathes in with a steady pull. Without fanfare, it slips through the iron bars as if stepping into a shadowed hallway that hums softly with the drumming of rain. Inside, the world changes the character. The noise is lower, more enclosed, with echoes that roll like distant thunder that no one worries about. The air is cooler and slightly earthy. The water roams along concrete channels that carry the city's rents. In many places, such stormwater moves toward rivers with few stops. In some places, pipes converge with those that move wastewater, and the mingling grows more complicated. But our traveler does not mind. It glides and turns through gentle bends, resting on the bottom, then rising with a swirl, bumping into tiny fragments of leaves, chaff from the edges of paper, little particles of soil, a sift of gypsum dust, a satin strand of polyester thread, a hair that curves like a green shoot in spring. Most of what moves here is not plastic. Most of it is the simple materials of daily life, tumbled by a passing shower. The fragment does not announce itself as different. It simply continues. The water opens into daylight again, the tunnel becoming a mouth that empties into a wide canal. The rain is easing to a mist that hangs in the air like a silk scarf. On the surface of the canal, there are swirls and patches of foam that look like cappuccino lace. Our fragment rides low and light, buoyant because of its chemistry, its polymer makeup that floats or sinks depending on what it is. Some plastics are lighter than the water, like polyethylene and polypropylene. Others are heavier, like PET or PVC. Some depend on temperature and salinity and the thin colonizing film that soon settles on almost anything that rests in water. A thin film of life will come almost inevitable as microorganisms find the surface and grow, lacing it with sugars and proteins, changing the way the speck moves. At first, though, it is simply a tiny piece floating among the foam patterns, unremarkable unless you decide to look closely. The canal flows toward a river. The river receives water that looks clean and water that looks brown. And there is no hurry, because this is a very long walk. You imagine a slow drift past reeds that nod with the breeze, past a quiet brick wall with moss seams, past a song of boat ropes rubbing the posts in a sound that seems like a purr. There is a faint scent of silt and something mineral in the air, and a sweetness of algae that you notice only if you choose to notice. Tiny fish flicker near the edge and do not take interest in our traveler. A water strider makes its own road across the skin of the river, using legs that press little dimples in the surface. Leaves revolve in small whirlpools that look like the flower of a galaxy. The fragment nestles against one leaf, then lifts as the leaf sinks and releases. In the drowsy light, everything is patient. If you let your attention wander, you might find yourself considering where microplastics begin. There are two common paths. Some pieces are made small on purpose, designed to be tiny for scrubbing or for the convenience of molding and transport. Others begin as larger objects that wear down or crack and fracture. The world rubs plastic like a soft stone in a pocket, wearing it smooth, snapping it into smaller bits when sunlight and heat and cold and bending strain it. Tires shed with motion. Synthetic fabrics cast off tiny threads during washing. Paint flakes and powder in weather. Nets and ropes and buoys that work at sea abrade with salt and thyme. Food packaging splits. Toys scrape on sidewalks. Furniture covers and carpets that seem stable release fine fibers every time you sit and stand and walk. Most bits are not traveling to a distant destination by intention. They simply become unstuck from where they were and go where water and wind and gravity invite them to go. Consider another traveler formed somewhere else in this same city. A long, invisible fiber breaks from the weave of a shirt in a washing machine and joins the wash water. The fiber slips from a sleeve or a seam. It has no color story now. It simply is a thread thinner than a hair, with a soft twist that makes it want to curl in on itself. The machine completes its cycles and tips the water to a pipe. That pipe leads to a plant that cleans water with steady, careful stages. Fine screens hold back things too large to belong. Grit chambers slow the flow so sand and heavy pebbles settle. Primary basins allow time for the heavier flakes to drift down and for the lighter scums to rise. Secondary basins add air and friendly microbes, which fold themselves softly around the glucose and proteins and fats that float in, turning cloudiness back to clarity. Clarifiers let solids settle, and disinfection, gentle and precise, polishes the water until it meets the agreed standard. Many fibers and fragments are trapped by these steps. Some join the settled solids that become sludges, which will follow their own patient routes. Some fragments, small and light and persistent, ride along with the clean water not as a failure with alarms, but as a reminder that fine particles are by nature stubborn and small. Our sidewalk fragment might join our laundering fiber eventually, both stepping into one river with two stories. The river is wide now, with barges moving like quiet islands. A gull glides on air with watchful ease, turning a slow circle. The water is not fast, but it gathers distance in a steady way. If this is a river with locks or weirs, the flow stair steps down from one quiet level to another. If it is free to wander, it meanders across its valley, slips around gentle bends, ladles sediments from its outer banks, and lays them down in loops inside. Our tiny travelers enjoy a row of calm backwaters where eddies cradle those who wait. They press softly into a tangle of roots and rest there until rain raises the water again and sets them loose. You may notice how often our travelers rest. Microplastics in the world do not move like arrows. They dawdle, they stop and start, they settle to the bottom and then lift again when the water stirs. They stick for a while to a leaf lit with algae. They spend time in the quiet shade beneath stones where crayfish shelter. They find old wood that floats and ride there for hours or weeks. Every pause is a chapter. Every release continues the same unassuming story. The gentle rhythm continues. The gentle rhythm continues. Time passes. The river narrows, then widens, then begins to show a taste of salt, a mixing of two waters that meet and fold into each other in an estuary with birds and reeds and a glaze of blue and green on the flats at low tide. Here, the physics becomes more layered, though it remains calm. The water slices into layers of temperature and salinity. Fine particles clump with the touch of salts, a chemistry that invites small to join small and become bigger. Some clumps are heavy enough to sink like a sleepy breath sighing down into a deeper bed. Our fragment may begin to carry a skin of life, a biofilm, like a thin, clear coat of sugar jelly wrapped with bits of living and dead cells. That living skin is a tiny, sticky city with bacteria that make the film and others that graze on it, and then grazers of grazers. The film is both shelter and pantry. It adds mass and slightly changes the balance of our traveler. Maybe it begins to spend more time under the surface now. One of the quietly fascinating things about microplastics is how varied their fate can be, and how much it still resembles an ordinary walk rather than a chase. Light ones wander the skin of the water like a slow skater. Heavy ones find the riverbed and settle. Any of them two can be pulled up again by a wind that ruffles the surface, or a boat that paddles by, or a tide that loops and lifts and lays things down again. Sand grains and silt settle with them, in layers that read like diaries of quiet weather. If a crab rests, it stirs some up. If rain falls upstream and the river swells, the settled layer lifts in little puffs and travels a bit more, then rests again. Perhaps our fragment rests beside a bit of oyster shell turned chalky by time. Perhaps it leans against an eelgrass blade and gathers a string of bubbles that look like a tiny necklace. Nothing announces itself as dramatic. The gentle rhythm continues. As our traveler inches from the estuary toward the open ocean, it passes a thin border that is not on any map. The estuary is a mixing bowl, with fresh and salt layered in subtle ways that tide and river push and slide. The open ocean is a wider hallway with a breadth that moves in long, regular swells. Far from shore, the tapestry of movement is no less complicated, but the scale stretches and the lullaby lengthens. Wind shapes waves over hours. Currents move like the belt of a slow machine. Eddies curl like sleeping cats. The sun rises and sets with the metronome of day and night. Our speck might raft on a floating strand of seaweed that purls with tiny bubbles at noon and relaxes them at evening. It might fall away to drift free and return again on the next tide. There is patience here and space. The open sea feels empty to the eye, but it is not even near the surface. Within the top few meters, there is a community of organisms too small to see without the help of instruments. There are drifting algae that carry out photosynthesis in numbers that make the arithmetic of oxygen and carbon possible for the rest of life. There are braids of little animals called zooplankton that feed and drift and nurse the eggs of larger animals. There are larval fish that look like tiny notations, pale translucent sigils with big eyes. Among these, our speck moves like an unremarkable pebble in a slow current. Some plankton find it and graze the biofilm the way a cow licks salt when walking by. Some pass without notice. Small copepods sweep their feeding appendages and sometimes pull in what the water carries. They can swallow the biofilm and the speck together. The speck may pass through and return to the water as part of the small, delicate rain that zooplankton make, which people sometimes call marine snow, when it aggregates and sinks. Or the speck might be set aside by a mouthpart sieve, rejected. Or it might be held for a while and then set free again. Each outcome is small. Each outcome repeats and repeats with no clang or surge. Our traveler persists. If the speck rides the surface for a time, sunlight paints it daily. Ultraviolet light invites the polymer chains to break, not in one bite, but in a slow weathering that cracks the surface and turns it rougher, less glossy. Salt seeps in. The film of life comes and goes with grazers. The edges prune themselves. The piece that once was one becomes two, then 3 tiny crumbs that feel at home in the silt between sand grains. The longer the walk, the more the little traveler resembles the fine dust that always exists in the world. The journey is not always toward the depths. Sometimes the sea gives back to shore. On a gentle morning, waves lean on a beach and roll the lip of water in a sheet as thin as muslin, pulling back and advancing over and over. The tiny fragment lands with this sheet, then slides out again, lands again, slides again. It nestles at last into the narrow space between the shells and the pearly mica flakes on the soft line where the last wave stopped. It rests there like a patient bead in a seam with the sun on its back. The beach is a place for many kinds of rest. Wind lifts dry sand into ripples that travel a few inches each day. Finer grains hide between larger grains. Everything sorts itself by size and shape in a rhythm that could lull a child to sleep. Microplastics here tuck into the pockets of the coarse sand or into pieces of feather and bits of dried seaweed. The colors are often muted. Sunlight fades many dyes over time, and the sea polishes the surface, taking away the shine. A walker with bare feet might not notice. A gull steps by, leaving a shallow track in the damp zone. The next tide or the next wind lifts the speck, moves it a hand's length, then a yard, then back, and the beach becomes another holding breath during the long walk. The story is not only about water. If you look up from the beach, you see the air itself, carrying small things with an unhurried authority. Dust from distant dunes arrives. After days in the sky, pollen floats like soft stars in the spring and early summer. Salt crystals climb up from waves in fine spray that rises and drifts and falls as fog that is too small to see. Microplastics, too, find pathways in air. Fine fibers become air travelers easily. They lift with the motions of bodies and breezes. Tire wear particles as fine as soot and often finer rise in the thermal currents rising off sunlit roads, then diffuse outward and settle not far or surprisingly far. Depending on how the air moves that day, light fragments can circle for hours before they find a place to rest. Sometimes the air itself is a quiet conveyor that carries these small passengers inland or out to sea. Gravity asks for them back slowly. Rain returns many. Snow gathers some in its clean crystals and brings them to the ground gently, releasing them when meltwater begins to roam. In a valley with a river and a town, a gentle snow has fallen. It hushed the street. The city is quieter. In that snow are flakes that formed high and fell through layers of air that contained dust and salt and perhaps a few fibers that now are folded inside the lace of ice crystals. They are not visible to the naked eye. They are simply there as part of the small material world. When thaw comes, the snow melts in clear trickles that wend their way to drains and then to rivers. There, microplastics find themselves continuing their slow migration. Scientists who study this cycle, the quiet atmospheric leg of the journey, set out sticky slides and place buckets in simple stands and take soft snow and filter it. They wear cotton clothes when they can to avoid adding their own threads, and they measure with care. Their laboratories, calm and tidy rooms with hoods and filtered air, become places where the smallest pieces of the world are invited to reveal themselves. Here, the fragments, the fibers, the spheres, and shards are illuminated through lenses that detect their distinct vibrations under infrared light or their crystalline fingerprints in Raman signals. Plastics have their own spectral signatures, like a whispering cadence that never changes. The scientists listen with instruments that hum and tally what the sky carries and what the ground receives. They breathe slowly, and they write slowly, and they remind anyone who reads their careful notes that the truth of small things lives in patience. Our journey returns to the water because the title of this quiet walk pulls us toward the sea, toward the unremarkable ways microplastics change oceans. Imagine now that the fragment we have been following re-enters the wet and briny world. Perhaps it rode an estuarine tide. Perhaps it came from beach sands. Perhaps it slipped through a river in an overnight surge. It meets the sea with no fanfare. The water opens wide beneath the surface, and light spangles down to where clarity allows. In places with a calm set of currents, small things gather. The ocean's surface is a geography, a subtle highs and lows made by temperature and salt and wind. Some areas give rise to convergence, where the skin of the water carries specks together, as if tugging on a sheet from all sides. There, seaweed collects, foam gathers, and fragments of many sorts drift together and part again. People sometimes imagine a dramatic island made of trash, but what exists is a thin peppering over many miles, a broad field of near emptiness dotted with small travelers like the one we follow, widely separated, visible only if you catch them in a net or on a tray, and then only the larger ones. Beneath, the smaller ones, free of the habit of floating, slip down, lifting and sinking with surface mixing, with storms, with daily warming and cooling, with the rise and fall of bubbles that burst and release little droplets sideways into the air. The gentle rhythm continues in silence, in repetition. Fish move through these layers, jellyfish and salps pulse. A transparent larva moves with a slight flick and finds a place to grow. Tiny snails graze at the surface film. For them, a microplastic fragment is not a destination. It is simply another bit among many bits. The relationship is not dramatic. It is subtle and everyday, intertwining with feeding and drifting, with the scent of molecules that algae release, with the plain physics of buoyancy. Some animals ingest small fragments along with their food. Some pass them without much effect. Some are bothered. Some barely register. Organisms differ, as they always do. Even where there is some harm, it is often at the scale of an individual, not a headline. This does not make the story less important. It makes the story true to the tone of the ocean, which is patient, which changes, because tiny things add up, because gentle rhythms repeated many times become a new baseline. Let us rest a moment in the quiet of the deep, not the very bottom, but the middle depths where light is a rumor. Many microplastics, aided by biofilms or by the clumping of organic matter, sink into this open world. Here, they may ride soft, sticky packages made of dead cells, mucus, and fecal pellets, the marine snow that drifts down in a very slow fall that can take days to cross a few hundred meters. This is a place where sleeping whales pass through like planets. It is richly inhabited by small creatures that swim just enough to hold position or rise to feed and sink to rest. Our traveler is a passenger on one of these flakes of snow. The flake gathers more as it falls, grows denser, and descends. Near the seabed, Currents push their hands across the sediment. The flake lands in a gentle puff, and the fragment slips into a tiny hollow among grains of sand and silt, alongside mineral bits and the skeletons of microscopic plankton and bits of shell ground into flour. The gentle rhythm continues above in the darkness. The daily vertical migration around night and day continues too, and that is its own lullaby. Sometimes ocean bottoms are not simply places of arrival. They can be busy with small lives that churn and mix the topmost layers, tiny engineers that move sediments upward and downward, bringing oxygen in and burying carbon out. As they dig their burrows and push aside grains, they lift and set down whatever they touch, including microplastics that have come to rest. A small worm might move a fragment a few centimeters. A sea cucumber might stir enough to lift it again into the neat near-bottom flow that fronts the seabed like a river that is always quiet but never still. The fragment can step off this underwater conveyor belt at any time, rest, then rise again. Currents that change with seasons add long cadence to this slow dance. Any of these cycles might be interrupted by a storm that reaches down, by a contour current that wakes again, by an upwelling that rises like the slow breath of the sea, lifting deep particles toward the bright surface where algae grin and gin again. Over time, there are many chapters. Each one is only gently different from the next. In polar regions, where the ocean wears a fur of ice in winter, or permanently, microplastics find another soft resting place. Sea ice grows by building delicate plates and brine channels that create a labyrinth. As the ocean freezes, it traps small things that hover near the surface. Air bubbles and salts arrange themselves into a pattern that looks, under a microscope, like geometry softened by water. Tiny algae bloom in those brine channels in spring, painting the ice with a secret garden of green and gold. Microplastics, if present in the surface water, join this delicate world patiently. Some stay until the ice melts. When the sun warms the ice and the pattern breaks, the small things return to the ocean in little cascades of meltwater that drop like soft bells. The ice had been a pause button. It releases its hold when the season turns. The walk continues. On land again for a moment, think about the path of microplastics that do not go to the sea right away. Some settle into soils when wastewater sludges are used to renew ground as fertilizer. That is a practical thing that many communities do, turning treated residues into material that returns nutrients to fields. In those soil crumbs, microplastics sit quietly in a matrix of minerals, clays, humus, and root hairs. Earthworms churn the surface gently, bringing some particles down and others up. Rainwater percolates through, as if the soil is politely sipping. Plant roots explore, turned by moisture and chemistry, not by the small beings that are woven into the background. Microplastics in soils do not vanish. They rest in aggregates. They slow. They ride the faintest of currents through pores, following the smallest slope that gravity can see. The wind may lift the lightest of fibers from a dry field and carry them a little further on. There is no rush. Time is immense. The gentle rhythm continues. We can press our ear to the long arc of a plastic object too. Take, for instance, a pellet that is shipped to a factory to be melted and formed into an everyday item. These pellets are small, uniform, easy to move by the thousand. They are sometimes spilled. A few escape a truck, a few escape a bag. They find gutters and ditches, then rivers, then the sea. They can be among the most visible small plastics on a beach, the way certain pebbles are noticeable because of their shape rather than their size. The pellet has not done anything wrong. It has simply followed the path offered to it. In time, it will become matte instead of glossy. It will crack and shard into little wedges and then crumbs. It will join the confetti that the shore and sea already hold. Each step is uneventful. Over years, the number of steps gives weight to the journey. Let us follow a different traveler for a while, one that began as a tire wear particle. Tires are marvels of engineering, blends of rubber, fillers, and fibers that grip and release the road thousands of times per mile. With each turn, tiny erasures occur, like pencil marks smudged by use. Most of these particles are small and dark and dense. Many settle near roads, caught in grasses, or in the top layer of soil, or they become part of the black dust that rain moves into gutters. Some float for a while, others sink quickly. In water, many of these particles carry additives and wear byproducts that are soluble or reactive. They form a quiet story about rivers and streams near cities. The work to understand them is meticulous and slow, as it must be. Instruments that can measure the parts that are not pure polymers, that can parse crumbed rubbers from other blacks, are brought to bear gently. The field advances by increments. Each observed stream and each counted sample is a calm remark, added to the margin of a much larger book. Meanwhile, our first traveler keeps moving. The sea carries it in its palm like a child carries a bead in a story, allowing it to trace loops and arcs on the surface before letting it drop again into the soft hush below. As it weathers, its surface becomes friendlier to attachment by life. The film changes from fresh to old to fresh again, an eternal spring of microbes whose universe is micrometers wide. A tiny diatom builds itself a delicate glass box on the surface of the fragment. A bacterium makes a sugar thread that glues neighbors into a raft. A single-celled grazer arrives in silence and eats. When it is done, it leaves a trace as faint as the dust on a windowsill. This is the order of things at a scale too small to see all of it carried by currents that wander the globe. There is a comfort in thinking about currents slowly. The ocean has its own set of highways that never get crowded, that take months or years to make a complete loop. Warm water rides high and cold water rides low. Winds push surfaces and set up gears that rotate like lazy wheels. The Atlantic has a long swoop from equator to pult and back. The Pacific has a broad turning under the North Star, and in the Southern Ocean, the water circles the world with a stride that is long and even. Our microplastic fragment is easily persuaded by these flows. It may spend time in a subtropical gyre, where convergence gently draws it toward the middle. It moves with the crowd, but the crowd is sparse, like the attendants at a quiet library on a rainy day. The gentle rhythm continues at the surface over weeks and months. The sun, air, and water slowly embrittle meniscus edges. Edges crack, surfaces check. A wave tucks an edge beneath and snaps a thin part into smaller bits. Those smaller pieces, in their turn, become easier to lift into the air when bubbles rise and pop. Sea spray is a secret elevator for tiny things. When a bubble bursts at the surface, it throws droplets upward that quickly evaporate, leaving behind salt and any small passenger in the droplet. These passengers ride the lowest layer of the atmosphere for a time. They might move a few meters above the sea before gravity brings them back in a mist you cannot see, placing them gently somewhere else. This exchange returns salt to the ocean surface and spices the air with a faint saline. It also allows microplastics to cross boundaries quietly. The cycle between air and sea is like an inhalation and an exhalation, steady and endless. If you find your thoughts drifting, you can rest them on something simple, like the feel of water on skin or the sweet repetition of waves arriving, each one like the last and yet slightly different, like breathing. It is fine to drift. The story will be here, soft and slow. A fragment might find its way to a floating mat of seaweed that winds together like braided hair. In some parts of the ocean, sargassum makes golden tables where small fish shelter and crabs import tiny households. On these shady rafts, microplastics are just one more ingredient in a salad of small things. Under a microscope, you might see them wedged among leaf veins and bubble stalks. Left alone, the mat moves with currents, travels hundreds of miles, meets storms and calms, and then decays and sinks. The microplastics go with it, then leave it, then meet another. The gentle rhythm continues. Consider now how people notice. The scale of microplastics invites quiet methods. Nets with fine meshes, sometimes called manta trawls because they skim the surface like a ray, collect what floats in the top few centimeters. The net is towed at an unhurried pace along a standard distance, measured like a walk in a park. The catch is rinsed into a jar and brought to a lab. There, tweezers and sieves and filters separate the lines by seat. Visual inspection helps, but it is not enough because organic bits can look like plastic, and plastics can look like shells. Spectrometric techniques answer gently. They ask the fragment to sing its fundamental tune, and they listen without raising their voice. The resulting spectra show peaks that align with the patterns for polyethylene, polypropylene, polystyrene, PET, P nylon, acrylic, and others. In this way, the lab creates a map of what the net found, and the scientist writes things down in neat lines. The writing is part of the lullaby. It is careful, it is contingent, it is not a shout. It tells a story that grows with repeated efforts in different seas, under different weather, at different times. When people ask the sea a question in this quiet way, the sea answers with numbers that are both small and large. In a liter of surface water, the count may be low, perhaps a fragment or two, perhaps none at all on some days. In a net pool that skims many cubic meters, there will be a handful, a few dozen, sometimes more. Spread across the area of an entire ocean, those small numbers become something to think about. In deep sediments, counts can be more than at the surface because sinking adds slowly over time. On ice, numbers can reflect what the water carried when the ice formed. On beaches, counts vary by tide and by season. None of these numbers needs to be shouted to be meaningful. They sit with us in the evening like a haiku that the mind can turn gently. Think now of the tools used to keep microplastics from entering water in the first place. In factories where plastic pellets are used, gentle screens and better seals keep pellets from spilling. Simple devices on drains collect pellets that escape. In homes, filters on washing machine outlets trap fibers before they go to pipes. Fabrics are made with tighter weaves and with fibers that shed less. Roads are designed with better capture of runoff. These are quiet steps, the kinds of adjustments people make when they care about a shared space. They are not dramatic. They are the steady kind of help that fits into the background of life. The gentle rhythm continues. Let us return to the rivers. Perhaps our traveler is near a delta now, where the land unravels into many fingers reaching into the sea. Deltas have tide lines that wander, embankments that seeking water shapes every year. Here, microplastics from upstream mingle with those from coastal towns, from fishing harbors, from farms. The sediments that carry them are young and soft. Mud flats shine at low tide. Wading birds work their quiet day on needle legs. The fragment nestles in this plain. It will leave when the next tidal surge lifts the top millimeter of mud and creates a milk of particles in water that moves along the bank. Perhaps the fragment will journey along a channel that is new this season, one that did not exist a year ago. Perhaps it will rest in a bend and ride out many tides before the right storm comes. Watch the water as night arrives. The surface seems to smooth out and then ruffle with small lines that look like writing. In the distance, a ship glides by a red navigation light. Sound travels differently over water at night, flatter and farther. The fragment does not hear or see. It only moves, as always, with currents. In the morning, the sky blushes and brightens, and the day begins again, and the sea repeats itself in a new way. The piece might nestle on the edge of a salt marsh and become part of the season's floodline, tucked in with the hollow stems of last year's grass. It might lodge inside a little snail shell that is half full of sand and wait there, patient, until time empties the shell with another wave. Between each step, there is stillness. Around the midpoint of our unhurried journey, a soft check-in can be a friendly tether. Still awake? Comment the secret word nebula. And now, whenever you are ready, let us drift onward with our quiet travelers. Consider the plastics that sink. Not everything floats once biofilms grow. A fiber of polyester or nylon might settle slowly, spinning as it descends through the upper layers. It might tangle with a flock of material sloughed from an algal bloom and find its downward journey accelerated. By the time it reaches the bottom, it carries a patina of the sea. The sediment here is a memory foam that accepts the new arrival and bears only the faintest mark. Over years, layers add themselves as thin sheets. The fiber becomes part of a quiet archive. If core samples are taken carefully by researchers, the annual layers reveal a history not only of natural processes, but of human artifacts. Pollen grains from years of abundant flowering, soot from distant fires, tiny shards of glass, and here and there a fiber that points to a year, to a decade. It is a sober but gentle timeline. In lakes, the same unremarkable patterns occur. A small city lake that accepts stormwater holds a set of spirals in its water column that move with seasons. In spring, as the lake warms, it stratifies into layers. In autumn, cooling mixes the layers again. Microplastics follow this breathing, spending the summer at the top, and then being invited to deeper waters with the turn of the season. If the lake is deep and clear, the layers are strong. If the lake is shallow and stirred by wind, there is less separation and more continuous mixing. Along the shore, rushes sigh and bend. Dragonflies twitch their gauzy wings. Swans drift. The fragments rest on the bottom until a fish tails by and lifts them a little, until a carpenter builds a dock and stirs the shallows, until a storm adds energy. When winter comes, in a cold place, the lake freezes over and stills. Beneath the ice, motion becomes subtle, like the slowed breath of someone sleeping. The gentle rhythm continues. People sometimes speak of microplastics as if they were all the same, and it is useful to recall their differences. Polyethylene and polypropylene are less dense than water and tend to float unless fouled. Polyethylene can be soft or hard, used in bags and bottles. Polypropylene offers stiffness and is used in caps and ropes. Peat is denser and often sinks, common in soda bottles and fabrics called polyester. PVC is denser still and used in pipes, remaining underwater when freed. Polystyrene, in its foamed form, floats. In solid forms, it often hovers near neutral. Nylon comes in fibers and in engineering parts, and as a fiber, drifts and sinks, depending on its composition. Each of these behaves differently as it weathers. UV light oxidizes the surface, introduces cracks, leaches color. Salts and temperatures push and pull on the material. The tiny fractures and pits become small habitation zones for microbes. The community of film creatures changes with temperature and with season. In warm seas, it grows more quickly. In cool seas, it takes longer. On land, in soils, the biofilm is different, made by organisms that prefer pores and humus, and it may be bound with tiny nodules of iron or calcium. In the atmosphere, films do not form in the same way. Less moisture, more UV, different chemistry. In each environment, the microplastic is not the same. It participates differently, like a guest adjusting to a room. Some fragments are companion to chemicals that were added during manufacturing, plasticizers that make things flexible, flame retardants that alter the way a material responds to heat, stabilizers, pigments, fillers. These are ingredients that, like salt in soup, make the recipe work. Over time, some of these can move from a fragment into the world around it. The pace is not the same in all situations. For this reason, microplastics are sometimes talked about as vectors for chemicals. It is a nuanced conversation. The ocean is a dilute soup with many other surfaces to which chemicals can attach. And there are also living organisms that concentrate certain molecules biologically. The extent to which microplastics carry chemicals in a significant way varies. The careful tone of research here is steady and restrained. Experiments with clean polymers and known concentrations are compared to field studies with diverse mixtures. Differences in salinity, in organic matter, in temperature, in sunlight exposure, in residence time, all matter. The literature grows with each gentle addition, the understanding refining like grain ground more finely. You may, at this point, notice how your body has settled. Perhaps the shoulders have softened. Perhaps the breath has evened. The story continues at this pace by design. Let us return to the shore and consider the tiny signs that might be seen if you sifted sand in a sieve. You would find spear-shaped fragments that used to be flat pieces, their corners now softened. You might find little dots of foam that are like meteorites when viewed up close, pockets of air locked inside. You might find threads that are uniform in diameter, with a faint twist that shows how they were spun and drawn. If a thread sticks to your finger with static, it is likely a polymer. If it bends and stays bent, it might be a hair or a natural fiber. The distinction is sometimes subtle. In the soft afternoon light, none of this feels urgent. It feels like a puzzle you can leave half finished and return to later, knowing it will be there. We move again to a harbor where boats sit on their moorings with black lines pitched to white cleats. Here, paint flakes sometimes drift from old hulls where anti-fouling coatings have weathered. Paint is its own family of plastics and non-plastics, with binders and pigments that behave differently from bottles and bags. Some of these flakes sink, some float for a time. Their colors can be bright even when the edges are worn. They mingle with fragments from packaging, with fibers from ropes, with crumbs from soles of shoes that walked to the quay and scuffed a step. The harbor is sheltered, and in its shelter, fine sediments accumulate. The microplastics do too, and the harbor floor is a collector. Periodically, it is dredged to maintain depth. The dredged material goes where the rules and necessities allow. Again, the journey does not end. The gentle rhythm continues. Beyond harbors, at sea, fishing gear and aquaculture equipment do their steady work. There are nets, floats, lines, cages, anchors, buoys. These are in motion almost constantly, rubbing where lines meet metal rings, working with the energy of waves and wind. That motion wears them in small ways. Fibers abrade and fray, creating fluff that was never meant to be free. It moves in the water like the down of a dandelion, though without the lift. Pieces bigger than microplastics can break off too, but they become smaller with time. The smaller they become, the less visible they become, the less likely someone is to pick them up immediately. Corporate and community practices to reduce gear loss and to retrieve what is lost help. They lower the steady background of contributing particles. They do not bring the number to zero. Nothing ever quite does. The sea and time are patient. It is restful to recall that most of the ocean is stable to a degree that comforts. The chemistry is buffered. The temperature changes are slower far from the surface. The details of life are distributed in layers, and the changes in those details take time to spread. Microplastics add to this canvas as a faint peppering. They do not erase the overall picture. They adjust it. Some animals learn to avoid them better with experience. Some do not. Some habitats accumulate more than others, the way leaves collect where fences bend the wind. The deep sea accumulates gently because everything that falls has only one direction. Arctic waters accumulate in sea ice for a season. Urban shorelines accumulate more than wild headlands. The gentle rhythm continues. On a fine day, a research vessel moves slowly on a grid course, towing a small net. The crew work with calm precision. There is little waste in their motions. They lower and raise, they rinse, they cap jars. Back in the lab, the samples are sorted. There is a ritual to this that feels almost liturgical. The lab bench is clean, the filters are weighed, the instruments are warmed and calibrated. There is a lab notebook, open and waiting, the date written at the top of the page. Each step is recorded. Even the blank controls that sit with the samples, catching any stray fibers in the lab air, are recorded. The data that emerge are like seeds that need to be sown in a field of context. They will grow into conclusions only when joined by others, when repeated. This slow tempo helps keep the conversation grounded. It helps your mind rest too, because it says that we do not need to leap. We can walk. We can measure, consider, adjust, and measure again. If you're drifting toward sleep, you are welcome to drift more deeply. Let the smoothness of the story be your pillow. But if you are still with the journey, let us consider the life of a biofilm on a microplastic. The biofilm begins with a few cells that sense a surface and stop to explore. They secrete a little glue and invite friends to stay. The friends respond to chemical cues, entwine themselves, and begin to lay down an extracellular matrix that is both home and infrastructure. Through it, water and nutrients flow. Waste flows out. The film is only a few micrometers thick, but it is busy. There are micro eddies at the edges where the current is stronger. There are micro-oxygen gradients. There is a population structure that intrigues microbiologists. Predators arrive that are only a few times larger than their prey and crawl over the film like moss spiders. When currents change, a piece of film sloughs off like a rag and drifts away. The film is replaced in days. The surface is never empty for long. It does not matter that the substrate is plastic rather than shell or wood. At this scale, a surface is a surface, a valuable commodity in open water. The gentle rhythm continues. In quiet fjords and sounds where glaciers once carved, another pattern shows. Fine silt streams from the rivers that drain mountains. It holds rock flour ground so fine that it gives the water a milky blue. Microplastics that enter here meet a lot of company in the form of suspended clays and silts. The small particles interact. They flocculate. They settle. The fjord is a repository. The sediments can be thick and layered. Contrast this with volcanic coasts where wave energy stays high and the bottom is made of rounded gravels. There, microplastics have fewer chances to settle permanently. They ride the wash more. Different coasts write different notes in the same score. You may picture deep sea canyons, those underwater river valleys that cut through the continental shelf. They are conduits for particles that the shelf waters move during storms. The intrusions of energy from storms push water down and along these canyons. The particles that ride these pulses include natural clasts, bits of old shells, and microplastics. The flow can be faster than you might expect in a place you cannot see. But even then, it lasts hours, then relents, and the ordinary slow settling returns. The journey is a collection of ordinary measurements. Distance across the seafloor is measured in centimeters or meters per day. Depth is measured in meters per 1,000 years in the layers. The gentle rhythm continues. In some places, microplastics have begun to press into the tissues of organismal study more than the water itself. Mussels and oysters live by filtering. They pull in water and strain it through gills. They are quiet and steady. Many small fragments pass through and leave again. Some lodge for a while. The animal has defenses that can move what does not belong into compartments that are less active. In fish, a similar pattern holds. Many studies, careful and meticulous, examine the presence of small fragments in stomachs and intestines. Lab experiments add exposures to defined conditions. The results vary. They point to a spectrum from negligible and transient to a subtle burden under certain situations. This is an area where humility is useful. It is comforting to think of science not as a set of answers, but as a willingness to keep asking in exacting ways, to let data accumulate like sand, forming a beach of knowledge that takes shape slowly at the edge of the unknown. Some researchers are looking even smaller, at nanoplastics, particles that fall below the size easily seen by microscopes that use light. Nanoplastics are made by further weathering, by mechanical abrasion, by cracks that work down to the molecular scale. Detection is difficult. Methods are evolving, drawing on advances in spectroscopy, microscopy, and thermal analysis. Results are not easy to compare across studies. The field is young and careful. The tone here is contemplative. Findings are offered with caveats. That, too, can help you rest. The world is not a sprint. It is a collection of measured steps. The gentle rhythm continues. We can pause on land again. Think of a city street glistening after rain, the drains humming softly, the gutters holding small treasures that children might notice when they crouched to look. A paperclip, a bead, a lost button. Microplastics among these are not likely to beckon attention. They are the filler of the scene. Their plainness is part of the story and part of why they matter. The tendency of such fillers to move outward along every available path is what changes the oceans, not through a single grand event, but through the repetition of these small departures. A little escapes here, a little there, over and over. In the span of a year, that is a lot. In the span of decades, that is more. The change is cumulative, like the way a stone step wears down under the soft pressure of many feet. Some of the most peaceful places on earth are alpine meadows and remote mountain peaks, and even there, on snowfields that glimmer under blue vaults, scientists have collected traces of plastics. The air is the courier there, and it does not hurry. It lifts from cities, swirls over fields, rides across lakes, and flows past branches and rocks and ridges, carrying the lightest fibers and a few fragments. When they fall with sheltering snow, they are preserved until melt. If a glacier flows, it collects decades of sky and layers that ice into bodies that move across centuries. When ice melts at the toe of a glacier, it releases what it held, not with fanfare, but with a quiet return. In that sense, the archive of ice is like the archive of sediment, holding on and letting go slowly. The gentle rhythm continues. Think about the future of our traveler. It may become small enough to join colloids in water, becoming so tiny that it is carried strictly by the buffets of molecules, not by gravity's suggestion. It may become welded into the structure of a sediment grain over time, with minerals precipitating around it and seaming it away from the open water. It may become encased in a piece of calcium carbonate that grows in the pore water between grains. It may remain what it is, a particle that drifts and rests and drifts again. None of these is a moment of drama. All are part of a slow editing of the world, in which the ocean writes in a pale script, erases, writes again, accumulates meaning in the margins. The human part of the story includes the ways we design and choose, and these too can be quiet. A fabric maker decides to use a yarn with a different filament structure that sheds less when washed. A municipal engineer installs a new screen in a stormwater system that traps fine debris. A shipbuilder chooses a paint that flakes less in sun. An outdoor gear company changes packaging to something that degrades more readily. A washing machine manufacturer includes a built-in filter that can be emptied like a lint trap. These are not events with fireworks. They are small pivots that, en masse, tip the balance little by little. If you imagine a dial in your mind, you can see it turn by degrees, not by leaps. The gentle rhythm continues. We can follow our traveler into a coral lagoon now, where the water is warm and clear and blue as a bell tone. The reef is alive with the business of daily life, fish cleaning other fish, parrotfish rasping at algae, tiny worms flowering from holes at dusk. Microplastics in this soft aquarium are not everywhere, but they are not absent. Some are wedged in the calcareous rubble that storms have made. Some are caught in the branches of tangling algae. Some sit in sand between coral heads. Tiny currents around coral polyps flutter banners of mucus that the corals use to clean sediments off themselves. Small fragments can be caught in that film and shunted away. On some days, the sea is so blue that your heart might lift. On others, a faint haze of plankton turns the water green. The particles are present on both days. The gentle rhythm continues. On a pier that extends into this lagoon, a person drops a fine meshed plankton net to sample the surface. They pull it in slowly and pour the contents into a clear bottle. Back at a simple bench under a shade roof, they look through a small hand lens. Among the copepods and small larvae, they notice a few colored specks and one tiny blue thread. They note them down. They will not deliver a manifesto. They will add a dot to a map. Dots become clusters. Clusters become the outlines of an understanding. The soft repetition of student after student, cohort after cohort, season after season creates a tapestry that is stronger than any single year. Imagine yourself now as a particle of microplastic, not as a spectator, but as the traveler. Not to become anxious, but to become small enough that the world is vast around you and time is generous. You feel the nudge of Brownian motion, tiny. Consider the slow stroke of a copepod's appendages, moving the water like a fan. Light above passes and dapples. Sometimes you are at the surface where the world is bright and a skin separates your water from open air. Sometimes you are a few meters down where the light is dimmer and cooler and the world is green. When you pass a patch of darkness, it is the shadow of a cloud. When the water warms you slightly and then cools you, it is the touch of day and night. When you tumble, you do so without strain. When you stick to a leaf of algae and then let go, it is like the briefest of handshakes. You do not decide where to go. The world carries you as it carries other things. You are unremarkable, and yet your kind, multiplied many times, makes a difference that matters. Along the coast of a continent, There are sandy beaches where waves curl with a warm, regular breath, rocky bays where the pulse is stronger, and muddy wetlands where the sound is a murmur rather than a crash. Microplastics arrange themselves accordingly. On sandy strands, they line the rack zone, stitched with seaweed, feather stems, and pale driftwood. On rocky shores, they lodge between stones like beads that slipped from a necklace. In mudflats, they disappear from view almost at once, soft-footed and tucked away. On each of these shores, cleanups by volunteers make a difference you can see. Bags filled with bottles and rope pieces and foam boards. The work is wholesome, social, gentle, sometimes meditative. The micro scale remains, for the most part, beyond fingertips. That, too, is fine. The large things becoming small will always be in the background work of the planet, both catching them before they begin their fraying and letting the small settle is part of a strategy that fits the tone of the system itself. If you think of the ocean as a breathing organism, inhaling and exhaling through the tides and winds, then microplastics are like dust motes in a sunbeam that a room breathes. They float, they settle. They are illuminated when light comes in at just the right angle. They are invisible otherwise. They are not the room itself. But too many motes over time can change how the room feels. That analogy, used softly, helps bring the conversation to a human scale without pressing too hard. It is not meant to alarm. It is meant to remind that accumulation, however quiet, arrives with repetition and patience. The gentle rhythm continues. In ports and shipyards, workers wear coveralls that sometimes shed threads, and they are often careful with what falls, sweeping and capturing. In stormwater canals, engineers have begun to install floating booms that skim the surface for debris. The booms are quiet. They sit and wait and collect and are emptied. In a neighborhood, a homeowner places a mesh sock at the end of a downspout to catch leaves and is surprised to see a small gathering of confetti and dust that takes longer than expected to accumulate. Not much each day, but something each week. The adjustment of behavior comes naturally, without slogans. When people see their small part, they often take a small step. The unremarkable long walk that changes oceans meets an unremarkable long walk that people can take, not with strain, but with routine. Our traveler spends a season in a calm bay. Day after day, the same birds arrive to feed. Fish school in the same patterns. The wind turns daily with the sun's heat, rising in the afternoon, dropping at night. The fragment is at the surface some days, below others. After many days, a storm comes that is more powerful than most. Waves with longer periods roll in and stir the bay down to its bottom. Under this energy, sediment is lofted in a curtain. Our fragment rises with the cloud and is drawn by outflow along the mouth of the bay. It slips beyond the headland into open sea again. Storm energy dissipates. The sea returns to its quieter routine. This is one of the ways distance accumulates, not in a continuous push, but in episodes when conditions are right. Between storms, there is resting. Between storms, there is less distance. The gentle rhythm continues. In the tropical Pacific, trade winds blow almost constantly. They pile warm water in a gentle dome. The dome's edge is a place of current, unshowy but real. A microplastic fragment that finds itself there will slowly ride west or east depending on where it started and on how the planet is breathing in that year. El Nino and La Nina alter this breathing in patterns that people have learned to anticipate. Sea surface heights change by a few centimeters. Currents shift by a fraction of a knot. Over months, those small differences sum to meaningful displacement. Our traveler is moved by these climate rhythms. When we say that microplastics change oceans, part of that meaning is that a constant, frictionless presence can interact with natural patterns in multiple ways. There is no single pathway. There is a multiplicity of roots that knit the globe with threads that do not glow and do not sing, but are there. Take a moment to rest on the shore of a lake again. Imagine twilight and a loon calling, the call stretching over the water like a silk ribbon. In that calm, microplastics continue to find their places, to rest, to resume. The world seems to hold everything together with a tender hand. It is restful to know that while the subject is complex, the activity, at the scale of each piece, is simple. The fragment waits, the fragment drifts, the fragment meets and parts, the fragment steps forward, the fragment pauses. The gentle rhythm continues. A tiny part of this story resides in how we count and how we speak. The language of calm science avoids making the smallest thing enormous. It also avoids making the small thing invisible. It says that persistence adds up. It says that quiet repetition changes baselines. It says that when you add a teaspoon every day to a bowl, the bowl will fill, not today, not tomorrow, but soon enough. And in a way that is not a surprise. That is a nice metaphor for this walk. Each fragment step is a teaspoon. Each tide is a day. The bowl is the ocean's many compartments. When the bowl is full enough to change what lives there, we will notice in careful graphs and in careful long-term monitoring. Many already have. The tone remains even. The notes are written with a calm hand. It is also good to recall that not all plastics are equal in their behavior over time. Some degrade faster. Some are collected more effectively. Some are used in ways that make shedding unlikely. The thoughtful arrangement of these variables is the work of many fields, from design to waste management to public habit. There is no need to create a hero in this story. There is no need to invent a villain. The protagonist is time. The plot is repetition. The setting is everywhere. The gentle rhythm continues. Now, imagine rain again. You are under a porch. The sound is a soft drumming as the shower threads its way through leaves. Streams form on the street. The water moves quietly toward a grate that has been brushed free of leaves by a neighbor who thought nothing of it except to help the water find its path. With the water go seeds, tiny crusts of paint, specks of soil, small insect bodies, fine fibers from clothes, bits of rubber dust, and here and there a microplastic fragment that might have been a corner of a wrapper long ago. This mixture is not a character in a story. It is simply what happens when the world is used and loved by many people and animals and plants all at once. That mixture is managed and blessed by the choices of communities and by the slow filtering of the world itself. The river and the sea are robust, patient filters. Their patience is not endless, but it is large. The ocean changes slowly and deeply. The long walk changes oceans, but the oceans also change the walk. The two are one story. At night on the open ocean, the sky is often clear in a way that can surprise. Stars parade from horizon to horizon. The Milky Way builds a humbling arch. Bioluminescence flickers beneath your hand if you stir the water, small sparks from small lives. Our little traveler moves through this night unchanged by the beauty we perceive, yet its motion is part of the same universe that made the stars and the sparks. A creature rises and accidentally tastes the fragment along with a bit of food. The fragment passes. The creature rises again. The calm of the night is not broken by this exchange. The gentle rhythm continues. On a research pier that stretches into the water, a glass funnel filled with clear water drips, slowly filtering a sample collected earlier. The filter paper is pale, and the flow leaves behind a thin ring where the last drops hang and fall. Under the microscope, a student sees a thin red fiber, a pale blue fiber, and two clear fragments that take up polarized light and flash faintly as the stage turns. The student notes them carefully, ticking boxes on a sheet. The supervisor nearby smiles softly and notes the consistency with previous weeks. Our minds can rest on this reliable, careful march. When we think about solutions, our mind can rest there too, because many are humble. Improved waste treatment trains with finer screens, street sweeping on a schedule that feels almost like tidying a room. Public bins placed where they are needed most, design for disassembly, education that is not loud but steady, incentives that align with how people naturally behave, intentional fabrics in public settings where shedding would be significant, filters in commercial laundries, capture devices at outfalls, river litter traps, fishing gear buyback, product stewardship, each a small step, each added to a list and implemented as ability allows. The gentle rhythm continues. A fiber that started in a sweater decades ago might now be a ghost of itself. It is shorter, paler, frayed. It has traveled through rivers and lakes and seas, perhaps into and out of a creature or two, perhaps not. It has rested on beaches and in muds. It has been drawn into air and returned to water. It is still recognizable as a man-made thing under a microscope. It did not choose this path. It followed the quiet instructions of physics and chemistry. In that sense, it is as honest as a pebble. We can allow ourselves to soften around this truth. We can place our effort where it counts, upstream in the chain and downstream in the treatment and everywhere in between where small habits live. When you imagine the future, you might see graphs that tilt downward slowly, indicating less shedding, more capture, less loss. You might see sediments that grow layers with fewer microplastic counts, a delicate stratigraphy with a peak and then a decline. You might see marine organisms with fewer extraneous items in their gut tracts. You might see nets that pull up less of what we did not intend. These are the kinds of changes that will be measured over years. They will not show up in a single summer survey. They will not be trumpeted by the sea. They will be recorded by notebooks, by data tables, by careful writing, by patient people. The gentle rhythm continues. Let us bring our traveler back toward shore one more time. Imagine a day with soft wind, the sort that turns flags lazily and wrinkles the top of the water like fine linen. The fragment rides in on a long, slow swell. It meets a sandbar and is hoisted gently onto it as the wave tips forward. It stays there for a while, warmed by the sun. A child runs by and does not notice it. An adult walks a dog and does not notice it. A shorebird dips its beak and captures a small crustacean hidden in the sand and does not notice it. The fragment is simply another thing in a world of things. The tide turns and the water returns, and the fragment floats again. Its walk always resumes. Its pauses always end. The gentle rhythm continues. The world at night in a bedroom is quiet too. You may hear distant cars, the soft rush of a heater, the tick of an old clock, a little rain that persuades you to stay. Your breathing is steady. Your body is heavy. The mind is light. You can imagine the sea and the tiny fragment still wandering there as you rest, but you do not need to hold it. You can let it go. It will walk without you. That is the comfort. The ocean will continue its slow conversation with time. Microplastics will continue their unremarkable drift. Scientists and citizens will continue their small, careful steps. The gentle rhythm continues. If you would like to imagine once more the start of the journey, you can. A rain begins, a street darkens, a tiny piece of plastic lifts and is carried along a shallow flow. It slips into a pipe. It enters a canal. It drifts to a river. It moves past reeds. It rests on a root. It slides free. It meets the estuary and mingles with brackish layers. It is coated with thin life. It sinks. It is lifted. It meets the sea. It finds a raft of seaweed. It leaves. It meets a calm convergence and is drawn to the center of a broad, thin gathering. It spins. It cracks. It becomes two. It becomes three. It becomes lighter and then heavier with life. It rises into a droplet and falls again as a speck. It travels a great distance by accumulating small arcs. It changes the ocean only by being one of many, an ensemble of unremarkable steps adding up to a slow nudge. It does this without intent. It does this quietly. The gentle rhythm continues. And as we reach the end of tonight's walk, know that you are safe and you are here, and that rest welcomes you like the tide. The oceans will keep their patient time. The tiny travelers will keep their simple routes. We can care and adjust and choose in ways that feel natural and calm, and we can measure with patience. If this story helped you feel peaceful, a gentle like and a subscribe help us keep making these soft explorations week after week. You can let the playlist in the description carry you deeper into sleep while you stay cozy. For now, close your eyes if you have not already. Let the gentle rhythm continue. Good night.